Question number 7. I have a figure defined by all those statements that I'm first going to analyze to overview the problem at hand. So I've got a circle of center O and 3 points A, B, C belonging to it, which means that OA, OB, and OC are radii of the circle. Later on, I'm going to call that distance x. And I've got another segment, which is two segments that are congruent, OA and OC. So this also is x. Another statement that I have is that O belongs to AB. It's just important to have those 3 points linear, which means that the distance AB is twice x. Then I'm going to consider the fact that DA is congruent with DC, and that will create a kite here, which means that this, which is 60 degrees, will be bisected by this line OD. And finally, DA and AB are perpendicular. And because I want to find theta, which is A, B, D, this is theta, I'm going to focus on this right triangle here. So let's do that. I'm going to focus on this triangle right there, A, B, D, knowing that this triangle here is a right angle, finding the tangent of theta. So the first thing that I'm going to point out is that since the line DA is perpendicular to the line AB, that implies that the measure of angle BAD is a 90-degree angle. It's this one here. Therefore, I can directly conclude that the tangent of the angle theta would be the opposite AD over the adjacent AB. And this is what I'm going to look for. For that, I'm going to define x, a variable, as the radius of the circle C. And because AB belongs to the circle C, and that O belongs to the segment AB, I can directly conclude that AB, because they are linear, is AO plus OB, which is 2x. So I have my first distance determined. Next, I will need to figure out DA. To do so, I'm first going to consider the fact that OA is congruent to the segment AC, which implies that OA equals AC equals OC. because they are all AO, OC are radii, and AC is congruent to that, which means that this is going to be a 60-degree angle. So because of that, I can conclude that the triangle AOC is equilateral, and, which is a property of equilateral triangles, equiangular. And therefore, the measure of the angle AOC is 60 degrees. Next, I'm going to consider the fact that the segment DA is congruent with the segment DC, which implies that DA equals DC. And if I add to that the fact that OA equals OC, since they are both radius, as explained earlier, I will have a kite with the line OD bisecting this angle. And so that would be 30 degrees. So I can conclude that the line OD is bisector not only of AC, but also of the angle AOC. Therefore, the measure of the angle AOD would be half of the measure of the angle AOC. And 60 over 2 is 30 degrees. Now, let's consider the triangle AOD. So let me jot that down. AOD. I know that this is a right angle. I know that this is 30 degrees. Therefore, necessarily, this will be 60 degrees. The triangle AOD is a 30, 60, 90 degree right triangle, and therefore AD would be equal to x divided by square root of 3. That's one of the special right triangle. So I've got now my second distance, and I can conclude. The tangent of theta, which is the opposite over the adjacent, would be x over square root of 3 divided by 2x. Both x's cancel. I will end up with 1 over 2 square root of 3, and after rationalizing the denominator, I'll have square root of 3 over 6. And that's it. Now, you can always check for the reasonability of your answer. You have a tangent, and if you grab your calculator and you apply the tangent inverse function, you get 16 degrees of an angle. And that actually matches what we have here. Look, if you consider not D, but this point on the circle, this point here, and if you consider this triangle there, you've got a 150-degree angle. I know that because it is supplementary of this 30-degree angle, and because those two are radii, that makes it an isosceles. And I've got 15 and 15 degree. So as you can see, the angle theta is just a little bit wider, and therefore that fits. That's it. Good luck.